Good morning, Rookie. Good morning, Lily.
Good morning.
All right. Sorry about that. I was just getting my stuff organized. All right. I forgot to close my door. I don't know why. So good morning. Happy Monday. How's everyone doing today? My cat's trying to answer you and saying that her day is not going well because I won't let her outside. So she's mad. All right. Can you guys hear me? Because nobody responded. I'm assuming you can hear me, maybe?
Yes, good morning.
Yay. Good morning. Let's see. Brady is here. Judith is here. Annie is here. Lee is here. I see Zevi is here. All right. So we're still missing a couple people, but that's okay. Happy Monday, right? I know you guys are excited to be here. I know you just woke up this morning and you were like, oh, if only class started sooner. I really want to get my Monday started, right? Yeah, see, I knew it. I knew it. I feel the same, right? So I think, I don't know what's going on. Does anyone have a class right before this class? No one does? No. My students in my class right before you guys definitely are not wanting to be there, whether it's just too early or Monday or whatever happened, but that group, it has really checked out and I'm really, really, really nervous for them. Yeah, I'm nervous that they're not going to finish successfully. Class is super boring. They just sit there like this. Some of them don't even look at the camera. So I know it's super sad. So I don't know what is going on with them, but it seems like that extended spring break really took a lot of the momentum out of a lot of people. So don't let that be you. I know it was terrible. I know it was. It was hard, hard, hard. But we just have a few more weeks left. We can do it. Some of you, it's the difference between graduating and not graduating. For all of you, it's the difference between moving on out of this class or retaking this class. And I'm pretty sure nobody wants to retake this class. Look at Brady. He's like, oh, no, that is not going to happen. I'm right there with you. I love all you guys, but I do not want to see you back in the fall in my same class. That would be sad. I'd love for you to just stop by for office hours and say like, hey, I'm rocking my next class, or I'm so excited, for whatever it is, but I don't want you to have to repeat this class. So that being said, you guys have a quiz this week, right? And you're supposed to make a video, right, for the review? And so far, this is how many videos I see? None. 0 videos. Yeah, it's sad. Yeah, 0. Can you believe it, Judith? And that's between both my classes. None, not one video. Yeah, so get your video up there, right? It's worth 20 points. Yeah, 20 points. So post your video, respond to 2 videos. It's going to be real hard to respond if you ain't got no other videos, right? You're going to respond to yourself like, I did a great job. I'm so happy I did it. But seriously, this could be a real easy way for you to get some points and to practice for the quiz. Yeah, so let's get it done. That homework wasn't super easy, right? PC6 wasn't super easy. A couple of questions were kind of annoying, right? Yeah. So, and then we just have PC7, and then you're all done with probability. And then we get to start finance. It's all about the money. Yeah. You'll like finance. I think you'll like finance. So most people do. So that being said, let's see if we can get in the right frame of mind by doing a mindfulness movement exercise. This one's a little bit longer. Okay. All right. Let me see if I can share my screen. You can turn off your cameras if you want. I haven't done this one in a long time. So it's like almost, no, it's 4 minutes. Okay, let's see. Let's make it full screen. All right.
Hey again, Caitlin here from Enso Theater Ensemble, and for today's Monday Mindfulness, I want to share with you a mindful movement exercise. So you can practice this in a subtle capacity, in public, while you're waiting for the bus, while you're walking to work, anything like that, or you can do this in a more expanded capacity where you actually integrate this into your audition warm-up or your rehearsal warm-up or something like that. Either way, this is a really, really nice practice to just add to your mindfulness tool set, and it also is a nice way to just practice continued self-care to your body. So the way that we're going to start is just with 3 deep breaths. Really simple. Inhale through the nose, exhale through the mouth. And as you do this, just notice if any thoughts arise, like we talked about in my last video, and try not to grab onto them when they arise. Just notice that they're there, and then redirect your thoughts to the exhale of your breath. So that breath might look something like this. Great. And then once you've created that little gap between whatever was happening in your day-to-day and this moment where you've decided to take a mindful check-in for yourself, then we're going to take your left hand and your right thumb, and you're just going to start creating a little gentle massage in your hand. And this might look like, I usually try to do some circles. Sometimes I start from the inside of my palm and work outward, just pushing and moving the skin a little bit. And this might extend out into your fingers. And if massaging feels a little funky, this can just be touch. It can just be like a really nice, warm sensation on your hand. All you're trying to do is to create an anchor, right? Again, it's a focus for where to bring your mind back to when you notice your mind has wandered. And as we're practicing this mindful movement, we're going to practice a little gratitude practice, and it goes a little something like this. I'm going to look at my hand and think about the ways in which my hand supported me today. So my day job is I do quite a bit of typing and sending emails. So I'm going to send gratitude to my hand today for sending all those emails and making me the money that I need to live. Thank you for making that possible. And then my massage might move down to my wrist, and it might move down to my forearm a little bit, and then I might think about the way in which my arm supported me today. One way that my arm supported me today is I gave my husband a hug in the morning, and I really appreciate that my arms allow me to express the love I feel for someone who's really important to me in my life. And then this movement might take you to your chest, and your chest does so many things for you because in many ways, right, our chest is protecting us. It's protecting our heart. It's protecting our emotions. We hold so much emotion and often anxiety in our chest. So just a little bit of love here, a little bit of gratitude that this part of your body was holding you today. And then you can move on to your other arm and all the way down and then into your other hand and just finish with this complete loop. And that's it. Really, really simple. So like I said, you can practice this in a subtle capacity by just like having your hand in your lap and just like, just doing some massage, practicing some gratitude right now. Or, right, you could take this into a warm-up. You could start with your feet and do your full legs and maybe even your torso up to your chest, all the way through your face. And you could really get every part of your body feeling really alive and zingy and also full of gratitude. So I hope you really enjoyed that. If you try it, as always, please let me know in the comments below and have
It cut her off, but I thought she was going to say, have a good day. I don't know. I don't know what happened there, but okay. Yeah, that was a good one, right? That's a good one. She's a little less, some of their voices are so soothing, they make you want to go to sleep. And she was a little less that way. She was a little more like, get ready for the day, like get energized for the day. So I appreciated that. So that's another one you can do. If you're finding some that you really, really like, get an app for your phone or something like that and really work through those mindfulness activities. I have a tendency to really, 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 my mind races. Is anyone right there? Like your mind just goes a million. Yeah. And you start doing something and then, so mine was cleaning, right? I'm cleaning and I walk into a different room to put something away. And then I notice that room is dirty. And so I start cleaning in that room. Anyone do this? And then you forgot that you were actually cleaning the other room. And so by the time soon an hour is gone and you never finished one room because now you've been in every room in your house and you've literally only put one thing away, right, in each room. So you have a mess on your hands. I have a tendency to do that. And it's really important to focus. You know how she said when those weird thoughts pop into your head, make sure you're able to refocus yourself. And that's what we need to do for this next period, 75 minutes or so. Make sure that we're really focused on the math. So it's important and it's hard because especially you guys are at your houses. It was almost easier when you went to class, right? Because when you went to class, you didn't have your pile of laundry that you could fold, or you couldn't walk in the kitchen and go grab a snack in the middle of class, or you couldn't hear your neighbors, whatever they're doing. Yeah, so we really need to focus. My cat is insane. Can you hear it? Yeah, I don't know if you can, but it's super loud. So I'll let it out in a minute. And Yeah, poor Zebby. Zebby has bad allergies, really bad, right? Yeah. So, and right now it's terrible. I went for a walk last night and couldn't stop sneezing for like an hour. It was insane. So, yeah. So, Zebby, feel free to put the ice pack on your head again. It's okay. We don't mind. So, it's fine. All right. So, we have one section left, and that is just combinations. Okay. So, I'm going to share my screen. We're going to do a little warm up if I can get there. All right. So in how many ways, let's just do number one. In how many ways can you choose a president, secretary, and treasurer for a club from 12 candidates if each candidate is eligible for each position, but no candidate can hold two positions? Okay. So think about that. Do that calculation and we'll share it in the chat in just a minute. Get it ready in the chat, but don't hit enter. I'm just going to make sure everybody has enough time to do it. If you want to write down your answer to number two or think about number two while we're still going over number one, that's totally fine. We're not going to put it in the chat for about maybe 30 more seconds. All right, so let's try number one in the chat. Let's put your answer in the chat. In 3, 2, 1, go. Look at that. It's so nice when you put it in and you have the same answer as someone else, right? That feels pretty good. All right. And V actually put the formula in there because this is a permutation. How do we know this is a permutation? What are the clues when I read the problem that tells me it's a permutation?
And no candidate can hold two positions.
Yes, in permutations, you definitely can't have repeats, right? And then the order matters in here, right? Like it matters who I pick for president and who I pick for vice president, or sorry, I guess secretary and treasurer. So it's important. You did not have to use the formula. You could have just said, okay, I'm picking 3 things. I have 12 for the first thing, 11 for the second thing, and 10 for the third thing. That's it, right? So you could do 12P3 if you want to, but you didn't have to. Okay. Any questions on that one? I like that you guys got it right. Good job. Now, the second one might be a little trickier. Don't get tricked by the second one. Did everybody have time to read it? So in the second one, it's a pizza place has pizza in 3 different sizes and 15 different toppings. How many one topping pizzas can be ordered? So I'll give you about 15 on that one. Okay, everybody have this one? Let's put that one in the chat. 3, 2, 1, go. Uh-oh, now we have a variety of answers. So let's make sense of this one. I know your guys are like, uh-oh. Now we have, it's not even like we just had 2 answers. We had lots of different answers, right? So when I read this, it says a pizza place has pizzas in 3 different sizes and 15 toppings. How many one topping pizzas can be ordered? First of all, can I repeat my toppings? Well, no, because I'm only doing a 1 topping pizza, right? So I don't, this doesn't matter, repeats or not. But is this a permutation? Or is it just the basic counting principle? Remember that basic counting rule? Yeah, V says it's the basic counting rule. This is where we really started in PF 6 or 5, maybe 6, I think. So we just have 3 different choices and 15 toppings. So we just have to multiply those 2 things. Remember that? Yeah, so don't get tricked and think it is. I bet a lot of you did 15, choose 3. Is that what a lot of you did? I don't know where some of those other numbers came from. I'm not sure. But so you have to be really careful and read the problem because the calculator is doing the math for you, right? So if you did 15, choose 3, that's where you got that 455. Where did the other number come from? Matt, do you remember how you got your number, your first one? Or Zach, 135?
Let me check my calculator.
What I did is I did the 3 times 15, but since I thought there was 3 different sizes, I just times that number by 3. But I see what I did.
Got it. Okay. Yep.
I did 15 to the 3rd power. So yeah.
Okay. Yeah. So it's really making sense of the problem. It's not the mathematics, right? It's understanding what it's really asking. So it's a little bit tricky there. Okay. So it's really all about the reading in these. So combinations, we still have that calculator if you need it, or you can use Desmos Scientific. But let's talk about how combinations are different than permutations, because some ways they're similar and some ways they're different. So in permutations, we had situations where we chose R items out of N possibilities without replacement, and where the order of selection was important. So, right, remember we were doing like who won a race, like came in first, second, or third, or president, vice president, secretary, those kind of things. But combinations are where order doesn't matter. So for example, let's say your teacher is picking 3 students. Do you remember when you were a kid and like she needed 3 helpers, your teacher needed 3 helpers to do this. And you were like, oh, anything to get out of class. I want to be the helper, right? And so the teacher chose 3 of you. It didn't matter if you got picked first or last because all 3 of you got to go, right? So that's a combination instead of a permutation. That's really the only difference between them. I mean, besides the calculation of how they happen. So don't be freaked out by this formula. Okay, don't be freaked out by this formula. The formula for combinations looks like this. So we're choosing however many items from the given items, and we find the permutation, and then we divide by PR choose R. Now, the reason we're dividing here is because if order doesn't matter, I need to get rid of these duplicate options. Okay, so for example, if I am choosing, let's say I have the letters A, B, C, D, E, and F, and I'm choosing 3 of them from these. Okay, so I'm going to choose 3. But I don't care which one gets chosen first and which one gets chosen second or which one gets chosen third. I just don't want to repeat them. So I could pick A, B, C, or I could pick B, A, C, or I could pick A, C, B, right? Or I could pick C, A, B, or C, B, A, or what else am I missing here? A, C, B, B, C, A. I could pick all of these, but do you notice that they all include A, B, and C? So in a permutation, each one of these would be counted as a separate outcome. But in a combination, all of these count as one outcome because order doesn't matter in a combination. So that's why I have to divide, okay? Because I have to get rid of those duplicates. So there's fewer combinations than permutations. Does that make sense? Okay, so you could do it with this formula, and I have it in my slides, but most of you are just going to use the calculator or a different kind of thinking like we're going to talk about. So don't get freaked out by that formula. I do have a handout for you. Let me put it in the chat so you can grab it. Oops. All right, so there's this document. And the first question says, in how many ways can 4 different pizza toppings be chosen from 12 available toppings? All right, so just to make sure we all love pizza and we know what we're doing, everybody put their favorite topping in the chat right now. Put your favorite pizza topping in the chat. You don't have to wait till I say 3, 2, 1, just put them in there. All right, we got a pepperoni. We got a pineapple. We got black olives. We have ham. What, Matt? Are you being serious?
Just trust me. Just trust me. It's great when it's 3 in the morning and you haven't realized that you're hungry, but then you get hungry and you it's great.
Okay, so I'm gonna put it down. It's terrifying to me. Whipped cream. Okay. Did I get sausage yet? Sausage. Oh my gosh, Brady. Yeah, you guys are all nuts. I think you just do it to get my reaction. I'm pretty sure that's why you're doing it now. Yeah, I know. It's okay. It's okay. Oh, Brazilian sausage. That must be different than regular sausage. We'll put Brazilian sausage on there too. Okay, so Tashina, you said everything. Can you name a topping that's everything besides whipped cream and chocolate syrup that would be something on your pizza? I want to get up to 12. One, two, three, four, 5, 6, 7, 8, 9. Mushrooms, 10. Anyone like green peppers? Okay, there you go. Green peppers. One more. Everybody's favorite, or I'm sure Matt and Brady's when they put whipped cream and chocolate sauce on it. Anchovies. Nice. Thank you, Matt. I was counting on you. Anchovies. I'm sure that's good with your chocolate syrup and your whipped cream. All right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I worked at Domino's and then I worked at another pizza place when I was a teenager. And at Domino's, when you make a certain number of pizzas in an hour, they would give the crew a pizza, you know, that you could eat like on your breaks and stuff. And everybody used to say, what do you want on it? What do you want on it? Well, you learn your lesson right away just to shut up and take whatever free pizza they give you, right? And but some moron on ours always put anchovies on every single one, and anchovies take over the whole pizza. If you've never had it before, I'm not saying I don't like it, but I'm saying like it takes over everything. So if somebody didn't like it, I don't know. So that was a little depressing. But if I was in charge, because I was a pizza maker, I would just accidentally leave them off and be like, oh, sorry, I forgot. So too bad for them. But it was a fun place to work. And I still make homemade pizzas like that today. I mean, I don't have all the Domino's equipment, but I'm a pretty good pizza maker. My kids are always like, can you just make homemade pizza? We don't want pizza from somewhere. I'm like, it's a lot of work, but I guess I can. So, okay. So here's our 12 available toppings. Now, I want you to think about this. Is this a permutation or a combination? When we're thinking about how many ways can 4 different toppings be chosen from 12 available toppings? So for example, let's say my pizza would have pepperoni, pineapple, black olives, and ham. Does it matter if I picked them in that order or if I picked black olives, pineapple, ham, and pepperoni? So does order matter or does order not matter? In a permutation, order matters. In a combination, order doesn't matter. So get your answer ready in the chat. Do you think it's a permutation or a combination? And you can just put a P or a C. You don't have to type out the whole thing if you don't want. Okay, so a P for permutation where order matters, or a C for combination where order doesn't matter. Ready? 3, 2, 1, go. Nice. You're all like, I know it's a combination because that's the section we're on anyway. So it should be a combination. You're right. It is a combination because order doesn't matter. It doesn't matter which item gets picked first, but as long as it gets picked. So this is a combination problem. Now, how do we do a combination problem? Remember, if it was a permutation, you guys would do this. You would draw your 4 lines, right? And you would multiply them. And what would be our first choice for the first item that we're going to pick? How many do we have to choose from?
Three.
There's 12 to choose from, right? Because I have 12 available toppings. So this is going to be 12. And if it was a permutation, I would just go 12 times 11 times 10 times 9, which is true for a combination as well, because I can't repeat. But now we have to get rid of those duplicates. And this is a way that you can think of to get rid of the duplicates. Like, what is my denominator? So remember, we had 4 choices for our first one because we're only picking 4 things, right? So I have 4 choices for my first one. Then that goes down to 3, then 2, then 1. So we're going to divide by 4 times 3 times 2 times 1. Or like V used in the initial part, you could use the combination formula and do 12 choose 4. Do it both ways, whether you do it on your Desmos calculator or that app, and then do it this way. And you should get the exact same answer. So do those calculations and we'll put it in the chat in about 30 seconds. Don't hit enter yet. All right, you ready? Let's put our answer in the chat in 3, 2, 1, go. Nice. Okay, that was really, do we know how to push the buttons correctly on our calculator, right? Because I told you what you were supposed to put in there. So, and it's real easy to make a mistake, right? On your calculator. If you do, I'm going to go to my Desmos calculator. If I do like 12 times 11 times 10 times 9, and then I try to divide, do you see how it's just dividing the 9 by that? So, and that can happen on your scientific calculator too. So a way to avoid that is you could put parentheses around the numerator. That's how we would normally do it. And then divide. Do you see how now it puts a fraction there? Or I can do it like this. That's why Desmos is kind of nice. I can hit that fraction button first, and then I don't have to do my parentheses. Okay, just so you know. So you can either put parentheses around it, or you can use that fraction button, right? Or if I want to know, if I want to use the combination formula because I feel pretty confident in it, then I can go function NCR and then go back to the main and go 12, 4. And you see I still get that 495. So, and if you're on this kind of calculator, I can't remember how to access it on V's, but I think V's got it now. So I hit, on my calculator, I hit 12, math, I arrow over to the PRB menu and I go down to NCR and then I hit 4 and I did get 495. It's actually a little more complicated on your calculators than it is on Desmos. But once you get good at it, it's not too hard, right? Okay. Any questions on that one? Notice if you would have done 12 PR, you would have gotten a different answer and it would have been much, much bigger, right? I can show you on this calculator. Remember that app we have? It looks like this. So if I do 12 and 4, notice my NPR is 11,880, but my NCR is only at 495. Okay, remember, because there's fewer combinations and permutations because order doesn't matter. All right. On your, if you're using your calculator, you'll want to write down like this. So the only bad thing about just writing down this is if you're wrong, right? Like if you wrote a combination and it was a permutation, you're completely wrong. So just be very careful, right? Yeah, if you're using your calculator, just tell me what you're doing, like C12 choose 4. Okay? All right. Here is it with a formula, right? Just in case you wanted to see that math. 12 factorial over 12 minus 4 factorial times 4 factorial. And then I just showed how it would simplify because this 8 factorial and this 8 factorial would simplify to 1. And you still end up, notice we get the exact same thing we did when we drew our line. 12 times 11 times 10 times 9 over 4 times 3 times 2 times 1. Okay? So don't be overwhelmed by that formula. When we draw our lines, we're doing the same thing. Okay, does anyone think they're going to win the lottery? Or have you ever watched that show, Winning the Lottery Ruined My Life? Have you watched that show? Yeah, it's a show. It exists, just in case you're wondering. I've watched 3 seconds of it. That's how long I lasted. So, but that's okay. Annie, it's true. Remember how we said how distracted I get? There you go. That's how distracted I get. Oh, and my husband turned on Bar Rescue last night. Have any of you seen that awful show? Yeah, some of you might like it, but he screaming, I can't deal with it. I left the room. And my husband's like, oh, did I chase you off? And I'm like, I just can't listen to him scream. I have better things to do with my time. So I actually like cleaned. It was terrible. And he was like, I was just finding something to watch. I'm like, I would watch reruns of Friends or The Office or anything over John Taffer yelling at humans. I just find it awful. And by the way, that show could be approximately 6 minutes long. 3 minutes to show how terrible it is at the beginning and 3 minutes to show how great it is at the end, and then just give a little update that, by the way, the bar still went out of business because the owner was a moron, right? That's what I feel like every episode is, but I'm just saying. Okay, that has nothing to do with the lottery. But the lottery, so one of my classes that I took, my major was, I was a statistician. Like, I have a math major, but my emphasis was in probability and statistics. So this is like my favorite thing. So I took an entire class, more than one, by the way, about combinations and permutations and things like that. So we did very intense problems and we investigated lotteries across the country. And so now we're to some lottery problems. This is called a 650 lottery game. So you pick 6 numbers that range from 1 to 50. Okay? 6 numbers that range from 1 to 50. And it says, how many different choices does the player have if order doesn't matter? Now, the key is, first of all, it told you order doesn't matter. So you know automatically it's either a permutation or a combination. But now you have to make that big decision. Is it a permutation or a combination? Okay. So here's the question. Let's just say I'm playing and I pick 1, 2, 3, 4, 5, and 6. And let's just say those are the winning numbers. Yeah. What do you think that likelihood is? Not very high. So, but I picked those numbers. Now, when you win the lottery, does it matter which order you picked those numbers in? Nope. Janessa says nope, and it's true. So, like, have you ever watched them do this? Like the lottery, like Powerball or anything? When the little ball comes up and it's like, oh, the first number is 8, right? Oh, the second number is 7, whatever it is, right? Okay, so, but it doesn't matter. If 8 is on your ticket, you're good. Now, Powerball is a little bit different because the Powerball is a separate number, right? So that one's a little bit different. This one that we're talking about right here is not the Powerball. It's just 6 numbers. So in this one, order doesn't matter, but I can't repeat. So if order doesn't matter, that's a combination. Okay, so if you freak out during the test and you're like, oh my gosh, I can't remember, does order matter or does order not matter on this problem? Or which one is a permutation and which one is a combination? Look at your calculator, right? Or your app like this. Since permutation has more than combination, then you know with permutations, order matters because that would give you lots more options. So combinations always has fewer options. So if you calculate them both and you're like, which one is actually the answer because you're having a test panic attack, if you can figure out that order doesn't matter, right, then you know it has to be the lower of the 2 numbers. Okay, so that's kind of a test taking strategy for you. So in ours, we are going to say we have these 6 numbers, 1, 2, 3, 4, 5, 6. How many choices do I have for the first number? How many am I choosing from? 50. Thanks, Lee. So this is 50. If it was a permutation, I would go 50 times 49 times 48 times 47 times 46 times 45, and I'd be done if order did matter. But order doesn't matter, so I need to get rid of those duplicates. So what do I start dividing by? Like, what do I put right here under that 50?
6.
Very nice. It's going to be a 6. Why a 6?
Pick 6 numbers.
Yep, because we're picking 6 numbers. So first we have 6 to pick, then we only have 5, then we have 4, then we have 3, then we have 2, then we have 1. And this formula right here, C50, choose 6, would give us the same answer as this. It will, I promise. Check it on your calculators. Get your answer ready in the chat. Okay, ready? 3, 2, 1, go. Nice. So nice when we get the same answers, right? So what is that number? That number is 15,890,700. So it's just like the permutation, right? Because we had 50 choices for the first number, then 49, then 48, then 47, then 46, until we picked 6 numbers. But now we have to get rid of those duplicates by dividing by 6 times 5 times 4 times 3 times 2 times 1. Okay? And the calculator will do all the work for you, right? You can literally just go to here. If we do 50, choose 6, and we say solve, it does it for us. You can see that the answer is that bottom one, combination. Okay, so the calculator will do all the work for you if you can just figure out if you need a permutation or a combination, right? 50, choose 6. Now, let's make sense of what that means, okay? So in this problem, you want to win the lottery, right? So you want to get all 6 numbers correct. That's what you want. You want to get all 6 numbers correct. So how many ways would you be able to get all 6 numbers correct? That's 6, choose 6, right? Yeah, there's only one way you can get them all right, right? Okay, so there's only one way. So the likelihood that you're going to win this lottery, I'm going to write this down, probability of getting all 6 numbers correct is equal to 1 out of 15,890,700. That's how likely it is that you pick them correctly. Yeah, it's a little depressing. Does it make you not want to buy a lottery ticket now? I know, but then they're going to say, you can't win if you don't play. Right? I know, somebody's going to win. It's true. It's not me, because I'm not playing. But I'm just saying. Okay. So does that make it more understandable, like why we would need to know how many ways we can pick these 6 numbers? So we're trying to figure out likelihood. We should look up what's the likelihood of getting struck by lightning. It's probably higher than winning the lottery. Yeah, it's a little depressing. Yeah. Okay. Here it is with the formula. Try this one. How many different choices does the player have if order doesn't matter? This is a daily lottery game, so it's way lower, right? So a player only picks 3 numbers, and you're only picking the numbers from 0 to 9. So how many different ways could you choose those 3 numbers out of the numbers 0 through 9? Okay, ready? 3, 2, 1, go. Hmm. Hmm. All right. So we have several different choices here. We have 84, 120, or 720. Those of you that got 84, I know exactly how you got it. How many numbers are there from 0 to 9? Count them. 0, 1, 2, 3, 4,
10.
6, 7, 8, 9. Yeah, there's 10. There's not 9. Anyone who got 84 did 9, 2, 3, didn't you? Yeah. Oh, it's not. It's not 9, 2, 3. It's 10, 2, 3. So the answer is 120. Now be careful, right? Be careful. So, and you can think of it like this, just in case. Now, those of you that got 84, you probably would have gotten it wrong this way too, because you didn't count, right? There are 10 digits, 0 through 9. But there's 10 times 9 times 8 over, and remember, we're choosing 3 numbers. We have 3 to choose from, then we have 2, then we have 1. So it's 10 times 9 times 8 over 3 times 2 times 1. I knew I was going to get you. It's okay. Lesson learned. Better to get it in class than later on, right? Okay. So the probability on here that you're going to get them correct, the probability on this one would be 1 out of 120, right? So that's way better than 1 out of 15 million something. Okay. I don't like this question, so I'm skipping this next question. I guess I better do it because there's stupid ones like this on more, even though I should just delete them all because they're pointless, stupid questions. Okay. What's the probability that if 6 letters are typed, no letters are repeated? Okay, no letters are repeated. Now, these can get tricky. And the reason they get tricky is if you think of this, 1, 2, 3, 4, 5, we'll put the other one over here. Do you notice it says probability? So this is a different question. This question, when it says probability, remember that's success to total. So we need to know how many total possible choices we have. If we have, how many letters do we have in our alphabet? 26, very nice. So if we have 26 choices for the first one, and 26 choices for the next one, and 26 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 for the next one, that is the total choices we have. I know that some of you are like, wait a minute, it says none are repeated. I agree with you. It does say none are repeated. But when I'm counting all the possibilities, I could repeat them, right? So that's why my denominator is going to be 26 to the 6th power. My numerator is going to be different though. And this is very similar to what we were doing before. My numerator is going to be 26. Oh no, sorry, that's a lie. Oh no, that's right. I was thinking of another question. Because we have 26 choices for the first one, but then we have to go down to 25 because we can't repeat 24, 23, 22, 21. Do you see how this problem is a little bit different than what we've been doing? Because it's probability. And so now it's not really talking about combinations or permutations, although it's vaguely referring to them. Okay. So, and then if you look, here's the probability that I'm not going to repeat any of them. Close to 50%, right? A little higher than 50% would make sense. Yeah, because there's a lot of letters in the alphabet. So we're okay. What about this one? Now read carefully. Repetition is allowed. As soon as you read that it says repetition is allowed, you throw out permutations and combinations. They're gone. Because you cannot use permutations and combinations if you can repeat. Yes? So as soon as you read that word, you're going to go, oh, well, this is not permutations or combinations, which is annoying because then I have to think harder. So it says, what's the probability? So it's going to be a fraction, and that they're all 5 going to be vowels. Okay, all 5 of them are going to be vowels. Now, you have to be careful on these because it's probability. Remember, the denominator is going to be 26 times 26 times 26 times 26 times 26. Because when we're talking probability, we're just saying, what are all the possibilities, right? Not just the ones that meet the criteria of my problem. That's where my numerator comes in. But my denominator is all the possibilities. Okay, so how many vowels are there? There you go, 5. A, E, I, O, U. So I have 5 choices for the first one. I can repeat 5 choices for the second one, 5 choices for the third one, 5 choices for the fourth one, and 5 choices for the fifth one. Do you see how this is tricky? Because it's in the combination information, but it's not a combination. Yeah, so that's annoying. So this is 5 to the 5th over 26 to the 5th, which gives you a very, very small likelihood, right? The likelihood that you're going to get all vowels should be very, very low, right? Because there's only 5 out of a total of 26. So I don't like those problems because they are kind of meaningless. I much prefer lottery questions, right? Because at least that's a real life application. Questions on that one? Okay.
I have a question. So I did the math and it gave me 2.630, like this weird crazy answer. So what I would do then is convert it to a decimal.
Yeah, so let's look.
I kept getting the wrong answer on more, and then I realized, oh, it's 5 decimal points, so I was forgetting to convert it.
Okay, so did you get something like this? 5 to the 5th, let me get it in here, 26 to the 5th. And did yours look something like this right here? V? 2.63016674 times 10 to the negative 4th. Yep. So when that exponent is negative, what it did was it put it in scientific notation for you because it wouldn't fit. So then we would convert it to a decimal. So, and that negative means we're going to move our place value 4 places to the left. Okay, 4 places to the left. So if I don't know if I can copy that. Oh, look, I can. Let me copy that and see if I can put it right here. I don't think it's going to let me, but maybe it'll let me put it off to the side. There we go. Okay, so this is what it looks like on your calculator. And so what we would do is that negative 4 would shift our place value 4 places to the left. So I did 1, 2, 3, 4. So my answer would be that 0.30 and then 2630. And then I just left it like that. And remember, on the test, I'm not going to do that to you, but I know on more, sometimes you algorithmically get a weird problem. So if you ever have that and you just keep getting the answer wrong, just click ask my instructor and say, I keep getting this wrong. And I can look and see, and then I can see what you got and I can give you credit for that. Okay. Good question, V. Okay. This is probably one of my favorite problems. And I want you to think it through. So in a lottery game, a player picks 6 numbers from 1 to 48. If 4 of the 6 numbers match those drawn, the player wins 3rd prize. I'll take 3rd prize. It's probably money, right? Okay. So what's the probability of winning this prize? Now, this problem is a little bit trickier because we're not trying to match all 6 numbers, right? We're just trying to match 4 of the numbers. Okay, so let's start off with just a baby problem first, okay, and say, okay, what are the chances? What's the probability I'm going to match all 6? Let's say I want to win, right? I want to match all 6. How many ways are there to choose 6 numbers out of 48? How would you do that part? How many ways can you choose 6 numbers out of 48? What would you do? Is that a permutation or a combination? That question that I just wrote. How many ways can you choose 6 numbers out of 48? Yeah, it is a combination because I don't care if you get picked first or last, right? I just want that number to get picked. So it's a combination. So you could do C, 48, choose 6, or you could do 48, 47, 46, 45, 44, 43. That's 6 numbers. And I'm going to divide because the order doesn't matter. So that's the denominator of my fraction. Yeah, that's all the possibilities. How many different 6 number combinations can I come up with out of the numbers 1 to 48? So what do you get for that part? Yeah, a giant number, right? 12,271,512. Does everybody get that number? Does everybody see where that number came from? Make sense? Very nice. Okay, so those are all the possibilities. So what if I wanted to get all the numbers right? How many ways can I get all of the numbers right? One, right? There's only one way that you're going to get all the numbers right, right? Yeah, like if you win, there's only one winning combination. So if it said you want to get all the numbers right, that's like P6 choose 6, right? If you do P6 choose 6 on your calculator, it's 1, right? Okay, so if I wanted to get all the numbers right, my probability would be 1 over this giant number. Here's the problem. I don't want to get all numbers right. I mean, I do, but I'm not going to. So I want to figure out, what if I get 4 of the 6 numbers right? Okay, so think this through. This is my denominator, because that's all the ways. Okay, so I'm going to get, out of the 6 numbers, I'm going to get 4 right, and I'm going to get 2 wrong. Do you agree? Like that's what the question is saying? 4 right, 2 wrong. Okay. How many total numbers are there? There's 48 numbers, right? Okay. How many of them are correct? How many of those 48 would be the correct ones? 6, right? 6 total correct. I'm going to get 4 of them, Josh, right? So I'm going to do, out of the 6, I'm going to get 4 of them right. So do you see how that would be C6 choose 4? Everybody okay with that? Now, if 6 are right and there's 48 total, how many are wrong? If 6 of the numbers are right and there's 48 total, how many of the numbers are wrong?
42.
There you go. So now out of those 42, how many do I need to pick? 2, because I'm getting 2 wrong. So that's your numerator. So our denominator was 48, choose 6. But our numerator is, here's my 4 right, here's my 2 wrong. And that's how you do this problem. Tricky? It's much easier if they just say you get them all right, because then it's just 1 out of that 12 million, right? But we can do it on our calculators. Let's go over here. Let's go to Desmos. Let's clear it. Let's go here. Make a fraction. Then we'll go NCR. Let's do 6, choose 4. And then we're going to multiply that by NCR 42, choose 2. And then we're going to divide that by, oh, it might need to, I don't know if it'll let us multiply this. Let's see. Let's see if it does it. NCR, I don't think it's liking this. 48, choose 6. Oh, now it did. So there's my answer. I just could put them all in there. That's kind of nice. I can get a fraction if I want. There's my fraction. But there's my decimal. So look at that. If I change that to a percent, there's 0.1% chance that I'm going to get 4 out of the 6 numbers right. That's pretty low. Yeah. So do you see what I had to do? Here I have it written out. I don't like how this is all jumbled together, but you have 4 numbers that are part of the jackpot, 2 numbers that are not part of the jackpot divided by the total. And that's how we get that answer. So those are a little bit trickier. Yeah. Okay. So tomorrow we'll do more of this practice. Let's look at what you have to do tonight. You can start on your more practice. Your probability review video is due tomorrow. And how many did I have so far? None. I have none. Okay, I have none. Now, my exit ticket can be tricky if you don't think it through. In my last class, 0 got it correct. 0. Okay, so let's see if maybe we can even get 1 get it correct here. Do you notice also I have some optional extra credit? It's a quizzes activity. Don't worry about doing that. Get all your homework done first and study for the test first. But on Wednesday, maybe if you're looking to do a little more practice, you could do the quizzes. Okay. All right. So that's it. I'm going to be quiet so you have time to do your exit ticket. And let me know if you have any questions. And then I'll see you tomorrow. Don't forget to do your videos. Videos, videos, videos.
Have a good day.
Great, thank you. Have a good day.
Thank you. Have a great day.
Great job, Lily.
Bye.
Bye, Matt.
Zona.
So I tried doing it like the permutation, but like it gave me a zero on my calculator, so I don't think that's the right way to do it, right?
Okay, so is the question a permutation or a combination?
I was thinking it's a permutation because it does matter since you have to have the 6 exactly,
Order does matter in this problem?
right?
How do you know order matters?
As well, we get to match all 6.
Yeah, but you don't have to match the first one with the first one. As long as your 6 numbers are picked, then you match.
Okay, I was thinking like you have to have the specific 6 numbers in order
You
to
do.
win.
Nope, not in order. You just have to have the 6 numbers to win.
Okay, so then it would be combinations.
Very nice. It is a combination. And what
Okay.
combination are you choosing? What are you using?
Well, 6 numbers, and then 44 would be the 6 would be, I don't know how to explain. Like on my calculator, I just do the 6 and then do the little math graph.
Okay, but you have to put in all the numbers first. So you're going to put in 44, choose 6, not 6, choose 44.
So that's
I'm
where
putting
I'm
it wrong.
confused, ma'am, too, because if I put that in, I'm just getting a number. I'm not getting a fraction.
Okay.
And
So,
so
but
then I went
how
back to
many-
it's a probability, so it's success over total.
Right. So that's your total. That combination number that you got is your total. So that's your denominator. So how many
Oh.
ways are the numbers correct?
6
No.
or 1. You have one, but there's
There you
6
go.
numbers that you have to.
So it's 1 over that combination number that you got.
Okay.
Uh,
So use my other calculator just in crap.
wait, why do I keep getting 0? I'm so confused. My calculator is weird. I keep getting 0 in all
I
of
don't
them.
know. Then use Desmos.
Oh, it doesn't. Okay, let's. It's me not know how to use
Okay.
or do fractions. I didn't know it doesn't go down any further because duh, it's 1.
Yeah.
Let's see.
Or you can use the app that I gave you.
So Desmos calculator, we use the scientific.
Yep. Just like this one.
I don't think I've ever used this. I
We-
have a handheld calculator.
Yeah, this, or you can use this factorial calculator, either way. This one's real easy too. I can put this one in the chat.
Okay. I don't think I have that one. Yeah, that would be good.
Desmos Scientific, I think, is the easiest.
I've been having a lot of computer troubles today.
I don't know what's going on with you, but you're all good. Good job.
I like just now I was trying to type it in and it closed me out, made me sign back in and all this stuff and said the file wasn't available. I'm like, what is going on today?
That's weird. Did you download the antivirus software that they recommended, that they gave all to us free?
No, I didn't know
Yeah.
I didn't see that in any email. I must not have been paying attention because you know how I am with reading.
Yeah, so let me see if I can, I'll send a message out to the whole class because I think everybody should do it.
Okay, yeah,
So-
all of us, like today I went to log in and my whole computer, like I could go through the websites, but my whole bar at the bottom, like where you can access files and turn your volume up and down, everything was frozen and it wouldn't allow me to, like the Zoom and everything was, and Canvas was all working, but it wouldn't like start the Zoom meeting, if that makes sense.
That is
So
weird.
it was super frustrating this morning.
Yeah, I'm sure.
This,
I what I did wrong. Sorry.
it's okay.
No, you're good.
I was just gonna say is, would it be better to speak with you or would it be better to do the tutoring in the sense that I'm better with